Good morning, honorable judges. Imagine waking up one day and losing the ability to move your own arm. For millions of stroke survivors, this is their daily reality. Rebuilding that muscle takes months of consistent therapy, but doing it alone at home, just using simple static rubber bands, is not just difficult. It can be highly unsafe and lead to injury. Hello, my name is Thomas, representing Team NeuroSync along with my teammates William and Farron. Today, addressing SDG number 3 for good health and well-being, we are incredibly proud to present our solution. AxoBox. AxoBox is a smart portable rehabilitation device that provides progressive resistance training for stroke patients. It uses AI to adjust the physical difficulty across different levels, making daily at-home therapy structured, measurable, and safe.
The hardware used. We use Arduino Uno, which is the brain for the whole project, and servo motor, which is for turning, and for sensor detects the pressure. An LCD display displays the text or numbers. An MPU 6050 is for detecting the angle. And we use more hardware, which is motor DC for spinning, and motor driver is to control the motor DC, and push button is to change the adaptive levels, and battery lipo is to provide the energy or electricity.
And this is how our robot works. So first of all, let me explain to you some stuff inside. First of all, we have the microcontroller. We are using an Arduino Uno. Next, over here, we have a motor driver, which controls the motor DC by spinning it. When you spin it, since it is connected to a rubber band, it will either tighten or loosen, and it will make it either easier or more difficult to pull the handle. Over here, we have the battery, which will power the whole project. Then, on both sides over here, we have two big servos. These are connected to two springs, which are hooked onto the handle. So it will make it either harder or easier for you to turn the handle. The two big servos respond to your turning. And over here, we have the MPU sensor, which will calculate the angle of the angle turned when you turn the handle. As you can see, the value here is changing. And over here, we have the force sensor, which will calculate how hard you grip the handle. As you can see, it's pretty big here. There we go. And let's see some stuff on the outside. We have three buttons over here. I'm going to walk through you one by one. So the first button over here, when you click it, it moves the servos. The servos here make it harder for you to turn the handle. Now you can do this 2 times. This is the hardest level. Pretty difficult. And when you click the white button the 3rd time, it'll go back to its original calibration. Now over here we have the second button, the green button. Now this will turn the motor DC. You can set it to your liking, and it will make it harder for you to pull. Now let's say I press this button 3 times. It's getting pretty difficult here. And finally, we get onto the last button, the red button, which will revert it back. It will loosen the pulling strength. To go back to the original calibration, you'd have to press it the same amount of times as you press the green button. So I'm going to press it 3 times. Now it's just as easy as before. And over here, we have an LCD. Now this LCD shows all of the statistics. First of all, we have F, which stands for force. It's how hard you grip the handle. As you can see, I'm gripping pretty hard right now. and the value is over 1000. Next, we have the angle, which is how much you turn the handle. Shows the angle by using this MPU sensor. And this force is calculated by this force sensor. Now we have the level system. Level 1 is the high severity of a stroke. You can't grip really hard and you can't turn all that much. That's level 1. Level 2 is if your grip strength is over 500 and you can turn. Now level 3, which is the lightest severity of the stroke, is when you can turn it over 75 degrees. As you can see, I am at level 3 because I can turn it really hard. Alright, so that is how our project works.
Problem. The first problem is static resistance. Traditional tools like rubber bands or basic weight are static. They do not adapt to the patient changing strength, making it hard to progress effectively. The second problem is limited accessibility. High-tech adaptive robotic therapy is usually only available in hospital, making daily access difficult and expensive for stroke survivor. The third problem is risk of injury at home. Without a physical therapist present, stroke patient risk muscle strain, overextension, or sudden accident if they drop their weights due to the unexpected muscle weakness. Solution. The first solution is progressive resistance level. The robotic mechanism dynamically adjusts the physical difficulty across multiple smart levels. As the patient gets stronger, the device provides harder resistance to ensure continuous muscle growth. The second solution is AI force sensing. Using integrated force sensor, the device reads the patient grip strength in real time, ensuring the resistance matches their actual capability. The third solution is active safety system and real-time feedback. AxoBox actively protect the user. It features ROM or range of motion limit protection and immediate drop force detection. If the patient hand slip or lose strength, the machine stop instantly. It also provides live status update via the LCD.
Currently, stroke rehabilitation solutions fall into two extremes. On one side, there are hospital robotic arms. These systems are advanced, but they are very expensive, bulky, and only available in clinical settings. On the other side, there are simple resistant bands used at home. While they are indeed affordable, they provide absolutely no guidance and no safety mechanisms. Because of this gap, many patients lack access to safe and effective rehabilitation at home. AxoBox, however, solves this problem with three key advantages. First, smart adaptability. Unlike standard resistant bands, AxoBox automatically adjusts the resistance level based on the patient's therapy stage. Second, independent safety. Features like an emergency stop and pain or release detection allows patients to train safely even when they are alone. Finally, portability. AxoBox is lightweight and affordable, bringing a physical rehabilitation tool directly into patients' homes.
Honorable judges, recovering from a stroke never be a dangerous struggle. With AxoBox, we bring the intelligence and safety of a clinic directly into the patient home. Through AI adaptive resistance and instant drop force detection, we don't just help patients rebuild their muscle, we help them rebuild their independence safely. That's all about our presentation. Hope you enjoy. Thank you.